Hello guys, welcome to another section of Math. Today we are going to look at how to differentiate natural log together with what? Absolute value of maybe any variable or maybe any trig ratio or maybe either with variable or what with a trig what ratio. But in our problem here is what? A trig what ratio, that is what? Cos x. We are more familiar with the derivative of natural log of, let's say, x. We all know that is what? 1 over what? X. We easily know answer to that. P will be 1 over P, K 1 over K. But what if it is absolute value of x, absolute value of K, absolute value of T? When you are solving that problem with maybe anyone, when they get there, they'll just tell you the answer is 1 over K, even when it is still absolute value of what? When it is still in absolute value form, they will still tell you the same answer, that it is what? 1 over X or 1 over what? K. But we actually don't know why they say it is what? 1 over that, even if it is still what? Absolute value form. Natural log of x is just 1 over x. Natural log absolute value of x will still give us the same 1 over x. Why? You don't worry, we are just going to find out at the end of this video. Though our problem here is what? Cos x. But you don't worry, the same approach is used when the absolute value involved is either a variable or what? A trig ratio. The same approach is what? Used. Okay, good. So let's write our solution to get started. Okay, so first, good. Now let's bring this one down here. Good. The derivative of natural log absolute value of what? Cos x. Now to solve this, actually we are not going to use the chain rule, but the workings will reflect the application of what? The chain rule. But we will not use the chain rule what? Directly here. Okay, so we are going to use what? Substitution to what? Solve this one. Okay, so we are going to first let y be equal to natural log absolute value of what? Cos x. Okay, so as I said, we are going to do substitution. But the question is, what are we substitute that variable for? This one or the whole of the absolute value what? Or the whole of the absolute value of what? Cos x. Well, here we are going to let u be equal to the whole of absolute value of what? Cos x. Okay, so that they mean something that we know better, or that we are more familiar with. Okay, so we're going to let u be equal to absolute value of what? Cos x. Now we know the derivative of natural log of x, that is 1 over x. Derivative of p will give us what? 1. Sine will give us what? Cosine. But what if it is what? In absolute value form? What is the derivative of what? Absolute value of cos x. How are you going to do that? Are you just going to write absolute value of sine x, or maybe absolute value of t, or absolute value of what? P? Well, to differentiate absolute value of any variable or any trig ratio, though we have derivative formulas for other differentiation questions. We have product rule when you have to solve something like sine x times cos x. You use the product rule, and when you have something like um, tan into bracket theta plus 3, you're going to get what? You have to use a chain rule to what? Solve that one. But what if it is absolute value of what? Cos x. Do we have any derivative rule or derivative formula for it? Yeah, there is. Yeah. To differentiate absolute value, you need two things: the chain rule and also the derivative rule for what? Absolute value. When you use the chain rule and you don't know the derivative rule for absolute value, you will find it difficult what getting the correct what answer at the end of the day. Okay, so you don't worry, we are going to learn something new here. I'm saying it is new because not all of us know how to differentiate what absolute values or absolute value of any variable or any trig what ratio. Okay, so we're just going to what find. I said we need two things: the chain rule and the derivative what rule. But here we will not use the chain rule directly. I said what we will do will reflect the application of the chain rule, but we will need the derivative rule to solve this one. Okay, so let's continue to find out what the rule says. Now, to differentiate this one, the rule says that first, don't take this one, maybe anything at all, absolute value of either x, absolute value of any variable, absolute value of any trig ratio, just the same word procedure. First, pick what is in the absolute value sign. So you just locate the absolute value of that particular variable and pick what is inside. So what is inside? That is here. When you come here is what? Cos x. Maybe yours may be x, yours may be tan, yours may be p. Just pick what is inside the word absolute value sign. Then differentiate that one first. When you differentiate it, just put it somewhere. Then you go back to the same absolute value again. Pick what is in the absolute value sign again, once again, then divide it by the whole of that absolute value that you are differentiating. After that, multiply the two answers together. So if yours is x, you're going to get the derivative of x to give you 1. So you're going to get 1 times. Then the next step is pick what is in the absolute value once again, and then divide it by the whole of that absolute value. So just pick, if it is x, we just pick x, then divide it by our absolute value of x. Then we multiply it by the derivative of that x, which is 1. So you're going to get 1 times x over absolute value of what? X. And that will give you as what? X over absolute value of what? X. You see? It's very simple. It's not that difficult. So let's apply the same thing here. So here first, what is inside the absolute value sign? That is cos x. You're going to pick cos x, then we differentiate. Sorry, you're going to pick cos x, then we differentiate it. Now, when we differentiate cos x, we are going to get what? Minus sine x. Now, let's put that minus sine x somewhere. The next one, you will not differentiate, but rather you will use it to form what? A fraction. You will not differentiate, but rather you use it to form what? A fraction. Okay, so let's look at how the fraction is formed. It says, pick what is in the absolute value sign once again, and then divide it by the whole of that absolute value. So what is in the absolute value here again? That is what? Cos x. So we just pick the cos x again, and then we divide cos x by the whole of absolute value of what? Cos x. And When you do that, we are going to get cos x over absolute value of what? Cos x. Now we are going to multiply the two together. The first one we had what? Minus sine x, and the second one we have what? We had what? Um, we had cos x over absolute value of cos x. Then we multiply these two together. So it's going to be minus sine x times cos x over absolute value of what? Cos x. And whatever that we get will be the answer to this derivative what? Question. Yeah, to be the answer to derivative of what? Absolute value of what? Cos x. And if this is one in your problem is not cos x, and it's, let's say, any variable, any t at all, just follow the same procedure and you get the same answer at the end of the day. The same answer does not mean getting sine and then there may be cosine, but yours may be t, so you're gonna get something like t over absolute value of t and the blah blah. So you're just like going to get the same thing as this one is going to what reflect, or going to what show. I mean, same format. I mean, same how the next step is going to look like. Yours is just good if if yours is maybe any variable and then you follow the same step, it's just going to get what? The same thing. Okay, so now now that we know how to go by, now let's differentiate it. First, it says differentiate what is in the sign. So what is in the sign is what? Cos x, and that will give us what? Minus sine x. Then we multiply by, now we will just pick this one again, and then we divide it by the whole of what? This, and that will give us what? Cos x over what? Sine, absolute value of what? Cos x. Okay, so du is equal to minus sine x times cos x over absolute value of what? Cos x dx. Now when we multiply this and this, whatever that we are going to get is the answer to the derivative of what? This. Now this is what I was talking about. If yours is p, when you follow the same approach, yours is going to look like 1 times p over absolute value of what? P. You see, exactly the same thing as this one is what? Showing. Okay, yeah. So that is how we differentiate what? Absolute what? Values. Okay, good. So now let's multiply this by this and see what you are going to get at the end of the day. Now du is equal to minus sine x times cos x all over absolute value of what? Cos x dx. Now the answer to derivative of what? Cos x is now minus sine x times cos x over absolute value of what? Cos x. Okay, good. Uh, I hope you are not confused, and I hope you have gotten it. Now let's move on to the other part. I mean, the main one. Y is equal to natural log of what? U. As I said earlier on, that we all know the answer to the derivative of what? Natural log of what? U. Which is what? 1 over u. But actually, we don't know how we got that 1 over u. All we know is that when my colleague was solving it, when he reached here, he wrote it as 1 over u, or 1 over t, or 1 over p. But we don't know why he is writing that 1 over t as the answer to the derivative of a natural log of t or u or x. Okay, so here I'm not going to write the answer directly for you guys, but what I'm going to do is that I'm going to use another approach which will give a proof, or which will show that the derivative of natural log of u is equal to 1 over u, or the derivative of natural log of t is equal to 1 over whole t. Okay, they say this does not mean it's going to be something very complex. It's very simple. It's very simple. Yeah, in exams you can't be showing, or if you are not asked to do, you can't be showing every work, and sometimes you have to go for shortcuts, just to go fast. If you decide to show every step, blah 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 blah, you wouldn't be able to finish what you are expected to do. Okay, so sometimes you have to omit some workings and just write the answer directly, especially those that we generally know answer to them. You just don't bother yourself giving a proof of why you had that answer, blah blah blah. No, but here, yes, I just want to show you that this is the reason why we say the natural log of any variable is equal to 1 over that variable. Okay, so what I'm going to do here is that I'm going to take e of both sides. Take e of both sides. Taking e of both sides reflects what? The definition of what? Logarithm. Okay, so if I take e of this side and I also take e of this side, the e and this one will just go away and I'll get my u back, and then we differentiate. Okay, so I'm gonna take e of both sides. Now let's take the e. Now this is what I mean by taking the e. Now this one actually reflects the definition of what? Logarithm. If to take e of both sides, we just consider what? The base of the natural log that is involved. The base of this natural log is e. So I'll just take that e of both sides. And taking of both sides means you are to take that e and whatever variable that is either on the left or the right hand side of the equation and use it to form what? An index. I use it to form what? An indices. That is, you are to write it as a base and a power. That is, you first write the e. Maybe on the left hand side, you write the e first, and whatever that was there initially, you write that one as what? A power. Okay, so this e becomes the base, and the whatever variable that was there initially becomes what? The power. Okay, good. So when we do that here, because this e, the base of the natural log is e, and already we are having another e here, this natural log and this e is going to cancel out and to give us what? U. So you're gonna get e to the power y is equal to u. Now let's differentiate. This one is very simple, so let's differentiate. When I differentiate this one, you're going to get e to the power y dy is equal to what? Du. Now let's find the y. You're going to divide both sides by what? E to the power y, and when we do that, we're going to get dy is equal to 1 over e to the power y du. Alright, now we are almost done with everything. Just that we have to find what? Dy over what? Dx, just to show that we are done with the differentiation journey that we started. Okay, so we have to, now that we are done differentiating this one, we have to find what is going to replace this one, and also what is going to replace this one in the x and the y word. I'm saying x and y word because with differentiation there are two variables are hot involved at a time. Okay, good. Okay, so going back to the x word, we are in y and then the u word, but it has to be y and then x world. Okay, so here what will replace what? Du. We know that du is equal to minus sine x times cos x over absolute value of what? Cos x dx. Okay, so we are going to replace this du with what? The whole of what? This one, including even the dx. Okay, and now we are going back to x and y world in bits. We've changed this one. We're going to change this one. I also got to change this one, but we will first change it to the u word and then before we get back to what the x word. I will not do it directly. Yours you can do it directly. Okay. Now this one is equal to what? This one is just right here, so I will not write it down for you guys. This one is equal to what? That is e to the power y is equal to what? U. So in our next step, you're going to replace this one with what? U. Okay. Good. Here we are not going to open the bracket, so we have to but here is what u. So let's find what is going to replace u in the what x word. Here also we know that x is equal to what? Sorry, we know that u is equal to absolute value of what? Cos x. Absolute value of what? Cos x. So let's replace this u with this absolute value of what? Cos x. So doing that, dy over dx is now equal to 1 over absolute value of what? Cos x times minus sine x times cos x all over absolute value of what? Cos x. Now let's open the bracket. When you open the bracket, this times this will give us what? Minus sine x cos x, and then this times this one will give us what? Absolute value what? Squared. Okay. Good. This time this one will give us the absolute value of what? Squared. No, I know some of you might still be wondering, I might still be thinking of we have differentiated but still we are seeing some absolute values here. So won't after differentiation, won't the absolute value be taken away? Will it still be part of the solution or what? I know some of you might be thinking like that, but you don't worry. After differentiation, remember I've told you that anytime you after differentiation, you have to do some computation as you are seeing here. You have to add, subtract, multiply, and divide some. Doing that will be what? Taking away some of the variables or some of the figures or some of the answers that you've gotten. Okay, so doing this one here, multiplying this and this is going to take away the absolute value. But how is it going to take away? Does it mean that when you have absolute value of x squared, the absolute value get vanished? Yes. When you have absolute value of, let's say, any variable or any trig ratio at all, and it's being squared, you're just going to get it what? That particular variable squared or that particular trig ratio what? Squared. So this one here is actually going to take the absolute value what? Off from the cos x. And you know why? The reason why we take absolute value of any variable or any trig ratio when we are integrating, or maybe when we are integrating, is that maybe the variable that was given in the question, maybe we have no idea that maybe when we integrate it, we have no idea that maybe is it going to be positive or what? Negative. Are the values going to be positive or negative? That one you can't tell. So to be on the safer side, you have to take absolute value of what? That variable or that trig ratio, so that at the end of the day, if it appears to be negative, you are safe. If it appears to be positive, you are what? Safe. So that is the reason why we take what? Absolute value. That is when we don't know that whatever we are going to get at the end of the day will either be positive or what. And if it is positive, we don't need the absolute value what again. But if it is negative, we just write the negative there. But here is the case, we don't know any of them that is either positive or what? Negative. So just take the absolute value, and the absolute value will what? Combine both. Absolute value of any variable means plus or minus of that variable, plus or minus of that what? Variable. So this one is just plus or minus of what? Cos x. But the absolute value always, or sometimes, let me say always, get vanished the moment the absolute value is being what? Squared. Do you know why? Any variable which is being squared will give you what? A positive answer. X times x will give you x squared. So even when the value of x is negative, when you square it, you're going to get what? A positive answer. That is the reason why when the absolute value is being squared, you get what? A positive answer. That is, the absolute value sign will get vanished. Okay? And the absolute value sign getting vanished does not mean you are getting just cos x back, just cos x or maybe t back or that particular variable back, but it means we are getting the square of that particular variable or maybe cos x what back. The moment you do that, the absolute value will just go off, because at the end of the day, no matter what the value that will be substituted in, we're just going to get what? A positive what? Answer, because minus 3 squared will give you what? 9, positive 9. That is minus 3 times minus 3 will just give you what? Positive what? 9. Okay, so here this absolute, because this times this one gave us absolute value of cos x all squared, we are going to get absolute value of what? Cos squared x or cos x squared. But we won't need the absolute value sign again, because cos x squared will always give what? A positive answer, or maybe absolute value of x squared will always give what? X squared will always give what? A positive answer. T squared will always give what? A positive answer, even if the value for t is what? Negative. Okay, so here we are going to get sine x times cos x all over cos x squared, and the absolute value what get vanished, because now we have become certain that the value for this one will be what? Positive. We have been assured that it will be what? Positive. The moment you square something, you have nothing to fear of about being negative or positive or blah blah. The moment you square it, if it is negative, it will be positive. Anything positive is going to be what? Positive. Okay, so let's continue. So dy over dx is equal to minus sine x times cos x all over cos x squared. You see, the sign has just got vanished, because when you say that let's say if here is t and you say that t is what, let's say minus 3, when you put that minus 3 there and you square, you're gonna get positive answer at the end of the day. Okay, so absolute value always get vanished the moment what? It gets what? Squared. Okay, and the reason is, the moment you square it, the answer becomes what? Positive. Positive answer is what? Assured. Okay, good. Now let's continue. So here, what can we do here again? All right, this can cancel out with this one. This can cancel out with this 2 here, and it will be left with was sine x over what? Cos x. Here we're having cos x squared, and cos x squared is same as cos x times cos x, and cos x times cos x, and then we divide it by this cos x here. We're gonna get what? Cos x. So here this cos will cancel out with this 2, and it will be left with what? Cos x. Okay, so dy over dx is equal to minus sine x over cos x, and we all know the short form for this. Sine x over cos x will give you what? Tan x, and cos x over sine x will give you what? Cotangent or cot s. Okay, so we are gonna get dy over dx equal to minus tan x minus what? Tan x. So the answer to the derivative question of absolute value of natural log absolute value of cos x is what? Minus tan x minus tan x. When you differentiate tan x, you are going to get minus natural log of what? Cos x. And if you want to get positive, you just rewrite the cos. That is 1 over what? Cos. When you do that, you're going to get what? Cos is the same thing as what? 1 over what? Secant. Cos is the same thing as what? 1 over what? Secant x. And to make it positive, you just reciprocate that secant and you just get what? Secant inverse of what? Let's say x, and then just bring that minus, because it's natural, just bring that minus 1 at the back of the natural log sign, it will be what? Positive. So ideally, sometimes when you integrate natural log, some of them will write it as minus natural log of cos x or natural log of secant what? X. They are all what? The same, just because it's just that when they reach the cos position, they'll just rewrite that one as 1 over what? Secant what? X. And they apply the negative index law of what? Indices, and it become what? Secant inverse of what? Cos x. And that minus 1 will just come at the back and to be minus minus and to be what? Positive. But here in our problem here, it was what? Positive. That is why we had this negative answer. But when we integrate this negative answer here, I is going to get the positive natural log of what? Cos. Positive natural log of what? Cos what? X. But I'll leave that one to you guys to try. If you're able to do it, just leave it in the comment section below for me to see. Okay. All right. So let's end it. Therefore, the derivative of natural log absolute value of cos x is equal to minus tan x minus tan x. Okay, so guys, I hope you now know how to differentiate not just natural log together with what? Absolute value, but if you are given any absolute value at all to differentiate, I hope you now know how to differentiate, and you also now know the reason behind natural derivative of natural log of any variable being equal to 1 over the variable. Okay, all right, all right, all right, all right. I hope you did enjoy this video, and if you really did enjoy, then please kindly give it a thumbs up, subscribe, and comment. Thanks for watching, and I will see you in another video. Bye.